We're going to play around with the left-hand side so that it equals the right-hand side. So I'm going to cross off 1 minus 2 sine squared y right now. Right over here, we're trying to get it so that we only see sine squared, right? So we want to get rid of cos squared. And we know with our identities, if sine squared x plus cos squared x equals 1, we can replace cos squared x with 1 minus sine squared x, right? We can do substitution. So we have 1 minus sine squared x, the minus sine squared x drops down. So then I have 1 minus, I have 1 sine squared, another sine squared, so I have minus 2 sine squared x or y. And that is what we had on our right-hand side. So check, we're done. Let's try number 6. For number 6, I'm going to play around with the left-hand side and try to get it so that it's tan squared x. I want to replace cosecant squared first. I'm going to try playing around with that. So I know cosecant is 1 over sine. I'm going to play around with the tan and replace that with sine over cos. And then this is all minus 1. So we can extend this line, and we have sine squared in the numerator and denominator. So we have 1 over cos squared x minus 1. And our goal is to make it say tan squared. So we know that 1 over cos is secant squared x minus 1. When we see squareds and ones, we think about our identities. Now if we go to our identities, we see sine squared x plus cos squared x equals 1. How could I play around with this so that I'd see secant squared? So do we want to divide by sine or divide by cosine? So if we can think about it. If we divide all things by sine, we would have 1 cotan, and we'd have cosecant, but we want secant. So we're going to try dividing everything by cos squared x. So sine squared x over cos squared x plus cos squared x over cos squared x is equal to 1 over cos squared x. Sine over cos is tan squared x plus cos over cos is 1. 1 over cos squared is secant squared x. So how can we replace secant squared x minus 1? Well, we can replace secant squared x minus 1 with tan, because if we isolate tan squared x, we would get secant squared x minus 1. So we can replace secant squared x minus 1 with tan squared x. And that is what we had in the beginning on the right-hand side. So we're good. We're done. We have 2 more. For number 7, we're going to play around with the right-hand side. It's a little more expanded. We're going to try to play around with it so we get tan squared x sine squared x. These aren't the same right now because the left side's a product and the right side's a subtraction problem. So let's cross this out so we don't get confused. Tan squared, we can write that as sine squared x over cos squared x minus sine squared x over 1. Now I need the same denominator, so I'll multiply the right side by cos squared x in the numerator and the denominator. So now we have the same denominator. It's cos squared x. In the numerator, we have sine squared x minus sine squared x cos squared x. So we have 2 terms in the numerator. The left is sine squared and the right is sine squared cos squared. We can factor out a sine squared x. So one thing you want to think about is, can I factor? Try playing around with sine and cosine, look at your identities. So if we factor out sine squared, we have 1 minus cos squared x over cos squared x. Now, when I look at this, I think, okay, do I have sine and cosine? Yes, I do right now. Do I have squareds and ones? Yes. I see 1 minus cos squared x. That's when I want to go play around with my identities. So again, we know sine squared x plus cos squared x equals 1. And how can I replace this? What can I replace this with? So if we had 1 minus cos, we could replace that with sine squared. So we'll have sine squared x, replace in parentheses with sine squared x, all over cos squared x. If we're trying to rewrite it so that it looks like the left-hand side, tan squared, sine squared, we know that sine over cos is tan. So we'd have tan squared x times sine squared x. Now we're done. Okay, last one, number 8. We're going to work with the messier side, so let's play around with the left side and try to get it to equal cosecant squared x. Now, first, red flag goes up when I see squared and a 1. I'm going to try to replace secant squared minus 1 using our identities. So first let me write sine squared x. If you're not sure, I always just start here rewriting this. Sine squared x plus cos squared x is equal to 1. And I ask myself, should I divide by cos or sine to see secant somewhere? Well, let's see. If I divide everything by cos, we have sine over cos is tan, cos over cos is 1, and 1 over cos is secant squared x. Now I need to rearrange this so that I see secant squared x minus 1. So if I subtract 1 from both sides, I have secant squared x minus 1. So I can substitute secant squared x minus 1 with tan squared x. So we have in the numerator secant squared x. We replace the denominator using our identities with tan squared x. Let's try using sine and cosine. So I'll write the numerator secant squared x divided by the denominator tan squared x. Secant is 1 over cosine squared x divided by tan is sine squared x over cosine squared x. We're going to change division to multiplication, flip fraction on the right. So I'll have 1 over cos squared x times cos squared x over sine squared x. Our cos's cancel in numerator and denominator. I have 1 over sine squared x, and looking at our reciprocal identities, we know 1 over sine is cosecant. So we have cosecant squared x. And now we've equaled our right-hand side.